right, coming at you from West Virginia again. This is not working, is it? Well, anyways, what does work is joke the day. So a Spanish magician tells his audience that he will disappear on the count of 3. And he counts, uno, dos, and then poof, he disappeared without a trace. I love that. Okay, but what's not going to disappear is graphing horizontal and vertical lines. Now, a lot of people get horizontal and vertical lines twisted. They get them confused. What they can do is they can put the point on the right spot, but then they get their line where it should be vertical, they make it horizontal and vice versa. But I have figured out a way that makes it very easy to graph these horizontal and vertical lines and get them right every single time. And it really comes down to reading the equation in a new way. So take a look at the example that we've got here. It says graph the line y equals 6. Now, we all read it as y equals 6 because that's what it is. It's y equals 6. However, let's take a look at reading it with a little bit of a twist to it. Instead of reading it as y equals 6, let's now read it as y has to be 6, because that's what the equal sign means. The equal sign means the y is 6. The y and the 6 are the same thing. Y has to be 6. So what we're going to do now is we're going to take a look at this 2D coordinate plane and we're going to say, okay, where is the y6 on this 2D coordinate plane? Is the y6 here? Is the y6 here? Is the y6 here? Or is the y6 down here? And you're right, the y is 6 right up here. Now, notice in our equation, it says y has to be 6. It doesn't say anything at all about the x. The x isn't even in there. So if the x isn't even in there and it doesn't say anything about the x, then that means, frankly, I don't care what the x is. I just need to make sure that the y is a 6 every single point on that 2D coordinate plane. Every point that I'm going to graph is going to have a y coordinate of 6. X can be anything. X can be positive, x can be negative, x can be 0. It can be anything at all. Just make sure that every point that we graph has a y coordinate of 6. So where else on this 2D coordinate plane do we have y coordinates that are 6? Sure, you've got a y coordinate of 6 here. You've got a y coordinate of 6 here. You've got a y coordinate of 6 here, and 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 here. Aha! And everything in between. So when we connect these, what type of line have we just made? You're right, that is a horizontal line. So whenever you have equations that look like this, and this is a b, and that b is just a number like a 6 or maybe a 3 or something, 5, whatever. So that, or even a fraction, y equals 2/3 or anything at all. So instead of y equals b, we're going to read it as y has to be whatever that number is. And that will help us to be able to graph that line perfectly. And like we said, whenever you see an equation that looks like this, y has to be whatever that number is, you are most definitely going to generate a horizontal line every single time. Every time it'll be horizontal. Okay, so let's talk about x and y intercepts. Remember, we now know that an x-intercept is where the graph crosses the x-axis. Mathematicians are not creative, so it's going to be an x-intercept where it crosses the x-axis. So here's my x-axis. Notice this graph right here. Where does it cross this axis? You're right, it doesn't at all. So therefore, what am I going to list as my x-intercept, being that the x-intercept is where it crosses that axis? You're right, I can't list anything. There's nothing at all that I can list. So I do not have an x-intercept. And folks, it's okay to not have an x-intercept. A lot of people will put this, they'll put, well, the x-intercept is 0. But you can't do that because that says there is an x-intercept. That says, okay, the graph does cross the x-axis, but you can see clearly this graph does not cross this axis. Another thing that a lot of people will put is this. But you can't put that either because this indicates that this point right here, the origin 0, 0, is where the graph crosses the x-axis. And again, you can see very clearly this graph does not cross at that spot. So I cannot list 0, 0. I can't list 0. I have to list none, or maybe you could list there isn't one, or don't have one, or something like that. But you definitely don't want to list a 0. You definitely don't want to list a 0, 0. Either of those indicates yes, it does cross, and it definitely doesn't. Now, let's talk about that Y-intercept. The Y-intercept, remember, is where the graph crosses this Y-axis. That's why it's called a Y-intercept. So where does this graph cross this axis? Yes, it crosses right here at this point right here. Now, we need the coordinates for that point. Since it does have a point of intersection, we need to know the coordinates of that point. Now remember, on this Y-axis, every one of these coordinates has no left or right movement at all. And if there's no left or right movement, then what is your x-coordinate? Yes, it's a 0. So, my coordinate for this point is 0, 6, because the y-coordinate is 6, the x-coordinate is 0. Now, I want to ask you, do you notice something special about this equation right here and this x-intercept, the coordinates for that intercept? Do you notice a similarity? Do you notice anything special? Yes. This equation says y has to be 6. Y has to be 6. Notice in this point, the y-coordinate is 6 because we were told the y has to be 6. In addition, in this coordinate, remember, if it's going to cross this y-axis right here, no left or right movement means that x-intercept has to, or not x-intercept, but that x-coordinate has got to be 0. It can't be anything else. If it's anything else, it's not going to sit on this y-axis. So in a general sense, when you have an equation that looks like this, meaning it's a horizontal line, in a general sense, that y-intercept is going to be 0. Its x-coordinate is going to be 0 because it's crossing this y-axis, no left or right movement, and the y-coordinate is going to be whatever that number is right there. Because the y-coordinate has to be that number. So therefore, there's your y-coordinate. And in a general sense, when you have a horizontal line, an equation that looks like this, then that means you're not going to have an x-intercept because most of the time it's not going to cross that x-axis. Unless, if your horizontal line is the x-axis, well then that's a whole other ball of wax. 99.9% of the time, your horizontal line, your graph that looks like this, is going to be off of that x-axis, sitting up here or down here, and you're not going to have an x-intercept. Now, with that in mind, take a look at this idea. So if I'm going to graph an equation that says x equals a, and that's how we all read it, x equals a, but I'm going to read it in a new way. I'm going to read it as x has to be whatever that number is. So in this example, this says x equals -3. I'm going to read it as x has to be a -3. So where is x a -3? Is it a -3 here, 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 or here? Where is x -3? You're exactly right. X is -3 right there. Now remember, if I'm reading this as x has to be a -3, then that means every point that I'm graphing had better have an x-coordinate of -3. I don't care what y is. It doesn't matter to me at all because y isn't even in there. Y is not a part of that equation, so y can be anything at all. It can be positive, it can be negative, it can be 0. Y can be anything. Just make sure that that x is a -3. So where else is x a -3? Absolutely. X is -3 here. X is -3 here, 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 and every point in between. So when I connect these, and I'm doing a terrible job because I'm doing it from the side, when I connect these, what type of line have I generated here? Yes, I have generated a vertical line. So every single time that you have an equation that looks like this, you will generate a vertical line every single time. So now let's talk about the x-intercept and the y-intercept. And remember that x-intercept is where this graph crosses that x-axis. Now as you look at this x-axis right here, where is this graph crossing this axis? Yes, it's crossing right here, and I need the coordinates for that point. Yes, the coordinates are -3, 0. Because on this point, we went -3, we started right here, we came back -3, and we did not go up or down at all for that point right there. So the y-coordinate's going to be 0, the x-coordinate's going to be -3. And just like before, do you notice something interesting between the equation and that point? Yes. This says the x has to be a -3. That meant the x-coordinate had better be a -3 in that x-intercept. And just like we said before, on this x-axis, there is no up or down movement. Any point at all on this x-axis, any of them, there's no up or down movement. So that means that the y-coordinate is going to have to be a 0. So like we said before, in a general sense here, when you've got that vertical line, meaning your x has to be whatever that number is, in a general sense, your y-intercept, you are going to have a y-coordinate of 0. I'm sorry, not not the y-intercept, the x-intercept. You are going to have a y-coordinate of 0 because anything on this axis has no up or down movement. The y-coordinate is going to have to be 0, and whatever this number is, that's going to be the x-coordinate of your intercept, because this says x has got to be whatever that number is. Now, let's talk y-intercept. And remember, y-intercept is the point where the graph crosses the y-axis. Well, here's that y-axis right there. Where is this graph crossing this axis? It's not. No, it's not. And like we said before, if it's not, don't put a 0, don't put 0, 0, because either of those indicates there's a point where it crosses. It doesn't. So that indicates none. I do not have a y-intercept on there anywhere. So, again, in a general sense, when you've got that vertical line, x equals whatever that number is, then that means in a general sense you are not going to have a y-intercept unless if this vertical line is this y-axis. Well, if that's the case, then every single point on that y-axis is going to be your y-intercept. And the similar idea here. If this horizontal line is on the x-axis, then your y-intercept is going to be every single point on that line. But like I said, 99.999% of the time, that's not going to happen. It's going to be off of these axes. So I hope this helps with those horizontal and vertical lines. And I do want to stress to you before I close this up that notice there's a lot of stuff that you feel like you have to have memorized. You feel like you've got to memorize, okay, when it reads like this, it's going to be horizontal. When it reads like this, it's going to be vertical. When it's horizontal, I'm not going to have an x-intercept, but my y-intercept is going to be 0, whatever that number is. And if it is a vertical line, then that means I'm not going to have a y-intercept. The x-intercept is going to be whatever this number is, 0. That's a lot to memorize. I would freak out. I would never be able to remember all that. And frankly, I don't. I don't have any of that memorized. The only thing that I have memorized is how to read it. And I now know how to read these in a new way. And because I now know how to read it in a new way, I can generate all the rest of this information. Notice that's what we did. I did not start off saying, okay, this means horizontal line, this means no x-intercept, and so on and so forth. This means vertical line, and it means no y-intercept, and so on and so forth. I didn't start that way. I started off saying, let's read it in a new way, and when we read it a new way, we graphed it, and we were able to pull that information out of the graph. So my point to you is, no, you don't have to have this stuff memorized. What you do need to know is how to read it. That equal sign means the two are the same. Pan balance idea. This and this have the same value. They are the same. So they have to be the same thing. And I hope that helps. Have a wonderful day.